Alright, this is section 6.2, part 4. Now we're going to try to put all the translations together. So if you have a translation of the function f of x equals a times b raised to x plus c, and the whole thing plus d. You've got the parent function y, or f of x, is equal to b raised to x, and b's got to be greater than 1. Then you have shifted horizontally c units to the left if it's positive here, and then c units to the right if it's a negative there. You have stretched vertically by a factor of a if a is greater than 0, compressed vertically if a is between 0 and 1, and if this is positive, you've gone up vertically d units. If it's negative, you've gone down vertically d units. If a is less than 0, if you got a negative in front of there, you have reflected about the x-axis. And if you have a negative in front of the x, well, then you have also a reflection that's going to be about the y-axis. Okay, so when you're trying to put all these together, make sure you follow the order of operations. So please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division from left to right, addition, subtraction from left to right. Okay, so let's graph this equation right here. We'll say the domain, the range, and the asymptote. And I've already got it graphed right here. But what we would do is we would take some points and we'd plug it in and we would get a y value. So let's plug in, say, -4. We'll plug in -4. We'll plug in, well, let's just plug in -2, -1, 0, 1, 2. We'll just stick with those. Okay, so 5, 3 times -2 minus 1 plus 2. So this will be 5, 3 raised to -3 plus 2. Okay, so that will be 5, 1/3 raised to 3 plus 2. And that would be 5, 1 over 27 plus 2. So 5 over 27 plus 2. Okay, well, let me get the calculator out here. So 5 divided by 27, and then plus 2. Looks like it's 2.19. So this is 2.19. Okay, let's plug in -1. Okay, so we've got -1 minus 1 plus 2. 5 raised to 3, or 5 times 3 raised to -2 plus 2. That is 5 times 1 over 9 plus 2, so that's 5 over 9 plus 2. 5 divided by 9 plus 2, 2.6. Okay, 0. Let's plug in 0. So 0 minus 1 plus 2, so 5. 3 raised to -1 plus 2, 5 raised to 1/3 plus 2, so 5 over 3 plus 2. 5 divided by 3 plus 2, 3.7. Okay, let's plug in 1. So 1 minus 1 plus 2. So that'll be 5, 3 raised to 0 plus 2. Anything raised to 0 is 1. So it looks like it's 5 plus 2, or 7. And then we'll plug in 2. So 5, 3 raised to 1 plus 2. Hey, that's going to be 15 plus 2, and that'll be 17. That's off the charts. Okay, so let's plug in what we know. Okay, so we have -2, 2.19, so just a hair above 2. -1, 2.6, so that is almost halfway. That's pretty much halfway. So -1, 2.6, that's pretty much halfway between 2 and 3, just a hair above it. 0, 3.7, so that's almost to 4. And then 1, 7, hey, there it is right there. Okay, and we also notice that b is 3, so it's going to be an increasing function. We notice that this is a plus 1, so we should have a horizontal asymptote at y equals 2, which is what we have right here. Okay, so then there's our function. Now you could plot many more points to get a very detailed drawing of this, but this would suffice for this, to get a few points and then to look at what's the domain, the range, and the asymptote. So let's look at the domain, which never changes, negative infinity to positive infinity. Here the range is 2 to infinity, and the horizontal asymptote is y is equal to 2. Okay, now let's look at in behavior of exponential functions. So for the parent function, f of x is equal to b raised to x. If b is greater than 1, so that means it's an increasing function. So it looks something like this right here, is increasing function. As x goes to infinity, so this is x going to positive infinity. Well, what's happening with our function? Well, it's going to infinity as well. Okay, so if it is a decreasing function, so something like this, so if b is between 0 and 1, that's a decreasing function. As x goes to, should be positive right there, as x goes to positive infinity, well, what is our function doing? Well, it looks like it's going towards, just for the parent function, it's going towards 0. Now, if we look at over here, if x is going to negative infinity, over here our function will be going to 0. If we look at negative infinity for x, as x goes to negative infinity, well, where's our function going? Our function is going to positive infinity. So let's look at this right here. So this is not our parent function. It has been transformed. So we'll have a rough graph of this. Okay, so let's have a rough graph. So let's look at b. B is 4. So it should be increasing. So it should be doing something like this right here. But notice we've got a negative right here. So we should be flipping over the x-axis. Okay, so it should be doing something like this. And then also we have a horizontal asymptote at -1. So let's say that here is -1. Okay, so our function should be getting closer and closer and closer and closer to that number. Okay, so let's get rid of this right here. So there's our graph, a very rough sketch of the graph. So as x is going to negative infinity, what is our function doing? Well, it's getting closer and closer to that -1. As x is going to positive infinity, what is our function doing? Well, it's going to go down towards negative infinity. Okay, so let's look at this one right here. We've got b is equal to 1/2, so we know we've got a decreasing function. Okay, so something like this, decreasing function. We have a horizontal asymptote at x equals 5. So let's just say this right here is 5. Okay? And we don't have a negative in front of the function, so it hasn't been reflected, so we don't have to worry about flipping it. Okay, so as x is going to negative infinity, what's our function doing? Well, it's going up to positive infinity. As x goes to positive infinity, what's our function doing? Well, it's getting closer and closer and closer to 5. And that's it.